Okay, last time we were together, we did limits using factoring, conjugates, and trig identities. Okay, remember that a little bit? Sort of. So, we factored, did conjugates so we could cancel, and then we had these trig identities that you had to remember, some of them. Okay, and you hopefully wrote those on your unit circle. All right, so today, what you're going to do is we're going to learn the squeeze theorem, and then you're going to have a quiz over limits over factoring, conjugates, trig identities, and the squeeze theorem. Now, the squeeze theorem is this. All right, I'm going to get colorful today. I'm going to grab green. Now, let's say there's a function that looks kind of like this. Okay? Now, let's say we wanted to find the limit at 0. Okay? But we're having an incredibly tough time of finding the limit at 0 for some odd reason. Okay? Now, the squeeze theorem says this. If we have a function above that is entirely above that function, and another function that is entirely below that function, who share a limit that intersects that function exactly, then the two functions that share the limit, whatever their limit is, will also be the limit of the original function. Okay? It seems like, why? What situation would have that? Well, it comes up, and that's why we study it. Okay? Now, the key thing is that this function has to be entirely above it. This function has to be entirely below it. Okay? So, for the squeeze theorem to work, it has to be in this type of situation. So, if we look at this situation, and then let's say we got a, and then we have a womp. Does the squeeze theorem work for this situation?
No.
Why not?
Because the red line goes above and below, so it's not entirely above and it's not entirely below.
True. Then that's something that you need to know. So if you have a line that crosses it, it doesn't work for the squeeze theorem. It has to squeeze together like a sandwich. And Calc will talk about a sandwich theorem because that's what he calls it, because it is sandwiched in between two theorems. So that's the way Sal does it, But officially it's a squeeze theorem, but he thinks it would be better called the sandwich theorem, and I get it. I get why he would call it the sandwich theorem. Okay? But they have to match exactly at a point. Like if you have one that hits it like this, and another one that hits it like this, you can't use the squeeze theorem because there are two different points. They all have to be at the same point for you to use the squeeze theorem. Okay? So that's the squeeze theorem. So before lunch, you're going to do the squeeze theorem, and then I'm going to have the quiz out there for you to do before lunch. Then after lunch, we're going to talk about discontinuities and continuous functions. Okay? So you should not have a problem getting the squeeze theorem done and doing the quiz before lunch. So here we go. You missed the whole